presentation demo. So hope you are all done great job till now. So in terms of motivating your teams and building the product, and from the next week will be the last week, and this I hope the learning curve is also very great because we have been going with many tight deadlines, right? And we will be having issues with data and with having issues with team members is not coming up. Sometimes they are coming up and sometimes they are not collaborating. So that might be issue. But in the meantime, you have been successfully uh, completed your chatbot architecture. So that is great to see. And we can go ahead with the team one presentation. Shantanu, you can go ahead.
Yeah. I'm just having a trouble sharing my screen again, so uh, just a moment. Uh, can anybody from Team One present the screen? Is anybody from Team One here?
I send you DM. Please send me the presentation. I'll share my screen.
Okay, great. Okay, as Ganesh, I have shared the presentation with you.
So everything is set, Shantanu, or do you require more time?
Yeah, as I'm not able to share my screen, so as Ganesh is sharing her screen, and I'm just waiting for her to start the screen.
Yeah.
Okay, I can see the screen now. So yeah, for the progress so far, first of all, we had a lot of trouble collecting the data. Since we are working with the depression, we find the data on Reddit, we scrape the data, that's fine. But in order to make the predictions, we need the label data. And to find the label data, again, there is like people with no expertise label the data or annotate the data. So we had to find out the data which is suitable for our task and labeled by health experts like a psychiatrist or psychologist. So I just reached out to the authors of the papers who hired the annotators to label the data. So we have a now label data. So now that label data is pre-processed and stored as a vector embeddings into the Pinecone vector DB. And apart from that, after that, once the data is stored, the next task is that the user comes on our platform. So the user will come to our chatbot and will give the credentials of the Reddit, their Reddit credentials, and based on that, will scrape the user's 3 to 6 months of history, or history of the like post and comments and their timestamps they were created. And after that, we pre-process that data, create the word embeddings out of the user history post and comments, and we do the similarity search with our vector DB. So once we do the similarity search, we find the majority labels associated with the that post in vector DB, and assign those labels to each post. Now, once each post is assigned the labels, we use the temporal algorithm to give the weights to each post. So here the idea is that we want to predict the user's current mental health. So in order to do that, we have to assign the weights, higher weights to the recent post and the lower weights to the older post. So here again we had three options: linear decay function, exponential, and the Gaussian decay function. So linear decay is not suitable because it, clearly, as you can see here, that linear decay function is not suitable here because we don't want the user's mental health, because ultimately, if you look at the major phenomenons in the nature, they are mostly either Gaussian or exponential decay. So Gaussian decay is also not suitable because it also not it doesn't get decayed that much as compared to the our project, because users mental health lasts long, at least 2 to 4 weeks, or maybe sometimes months. So it's like 2 to 8 weeks or 10 weeks at max. So if we look at the graph, you can see that the exponential decay
Sorry for
function.
interruption, Shantanu. Can you have the presentation to be larger? Like it's very small, right? So
Yeah,
uh,
sorry about that. I can open on a larger screen. Do you have in cloud? So I can open on a browser, Shantanu.
uh, well, I shared the file. So, like, what are
Yeah,
you
but
asking?
I don't have a specific format to open in my PC. So if you have on cloud that I can open on a link.
Let me see.
I don't think you necessarily need Microsoft PowerPoint. I think your Mac should be able to open it up in Keynote.
Yeah, maybe you have to download it.
Okay, there you go.
Okay, great. So can you go to the last slide? Yeah. So here you can see that there are as we discussed that uh, we have three options to choose the temporal functions, whether we want our weights to decay at linear, Gaussian, or exponential. So in exponential, there are now multiple options. So there isn't any research which is backing that users mental depression lasts long for like a couple of weeks or maybe months. So as we took the approach that users mental health lasts for like 8 to 10 weeks at max. So after 10 weeks, we don't. So the post which are within the 10 weeks from now on will be given the weights, and after the 10 weeks, the whichever the posts are there will not be given any weightage. So here you can see the graph that will choose a line which is not giving the weights, zero weights after the 10 weeks. So we'll choose the exponential decay with the lambda value of 0.5, and that's how we built our temporal algorithm. So, and after that, we have a user interface where user history will be scraped, and user will be given that, okay, you are going through the severe depression or based on the post history will be given that okay, you are going through mild depression or one of the categories of the depression. So, and based on that, will recommend either you do the yoga and all. So right now we just have the uh, uh, we have very less collaborators here in our team, so we are not able to put it together from front end and back end. So maybe in the next call we'll be able to show the demo. Thank you. And if you guys or as a Basant or maybe someone else can give us the idea, either we are going in the correct direction or not. Is it the way we should go forward, for the temporal algorithm, or maybe we are doing the similarity search to get the labels for each post? So is it a good approach or not? Uh, would love to hear the inputs from others.
Okay. So any inputs, any questions from the members? Okay, no questions it seems. Okay. So as said, team one is presenting demo on Wednesday. Okay, so no problem. So now we can go ahead with the team three. Is that done, Shantanu from your team?
Yes. Yes, yeah.
Okay. Okay, then team three, Yani and team.
Hello, Yaya. Hi, nice to meet you, everyone.
Yeah.
First, I would like to clarify with you, Yaya, for the purposes of time, we have prepared slides, but we also have 2 demos to present. So I'm going to leave it up to you. How do you want us to go with this in terms of time for the purposes of time? So if you could please let us know, we can proceed with this.
Okay, sure. You can go ahead first.
Sorry?
You can go ahead.
Can we do the presentation and then the 2 demos? I mean, at the same time.
Yes.
Okay.
Yes.
Okay, sure. No problems at all. Let me share my screen. Can I get some feedback, please, if everybody can see my screen?
Yes.
All right, great. Thank you very much. Right, so sorry, let me start again at the beginning. Right, hi everyone, we're team 3, and with this, we would like to present our 2 approaches actually for the solutions that we found for our system. So let's start now. So the way how these slides are, again, we start with the team updates, active collaboration. We have 2 architecture which we're going to present. We have data collection, data preprocessing, and again, model building as well. We have made some changes, obviously, about data collection team. Well, the numbers have been reduced because not everybody collaborated in our project as well. The way how this data collection was, it's the same as last time. We have scraped data from multiple sources, but we went over with one data that we found, which is already cleaned as well, and it was already assigned with polarity as well. This was one of our leads, Chris. He found the data. It was in a spreadsheet. But other than that, we found multiple state from multiple sources, from Kaggle, from Hugging Face, and it was from other places like the governance platform as well. And the data that we were looking for was based on question and responses, or just conversations from places like Reddit as well. It was the way how we select for the purposes of this project. And this was, again, like same as last week. I'm just going to explain why we were choosing this, because they provide more structured format for collecting information and making it easier to organize as well. And it was targeting, we were trying to target specific mental health because we chose our 3 categories, which was anxiety, depression, and ADHD. And we were trying to select them in 3 categories, like moderate risk, mild, or the user in severe at risk as well. The same that we faced some limitations that we had to overcome, like the ethical considerations. So data had to be from open source with consideration of ethics and validation and accuracy as well. And obviously the part about self-reporting as well, there were some, when we were trying to collect data, it was also the ambiguity as well, whether the user, whether users are actually aware of their the mental health state and what they're reporting. They may be under-reporting or over-reporting as well. But we're assuming that in this data, this is not the case here. So this is our data pre-processing team. Bibi is now the lead for that as well, because Abhishek, he's not here anymore. So these are the changes that we have here for our team as well. And data pre-processing team, we're generating the data in the format of question. We have mental health issue categories, and it answers the question of severity. Does the user need immediate help? Are they in severe risk? Also asking the question, do they need help? Is it a mild case, or let's say a mild case of depression? Or are we answering the question whether or not they they do not require help, or maybe they're not at risk as well? So this is what we're trying to answer here. This is our model building team. Our leads, Bibi, Araf, and Jalin, they've done an amazing job as well, and I would like to do some special thanks as well to Abhishek as well. They were incredibly helpful in the way how they collaborated and they built this whole architecture. So this is our chatbot design and architecture, just the same as last week, except that we added the reinforcement learning here as well. The user is asking questions to the chatbot, and then the chatbot processes the question, and we have a state of mediator as well. And then we're storing this in a vector store database as well, and then we're generating back a response as well. We have two approaches here that we went with this project. So we have reinforcement learning architecture, and we also have a RAG approach here as well, for which I would invite one of my colleagues. I believe Jalin is on the call as well, so she can talk more about the comparison that we do here between the two as well. Jalin, yeah, feel free to. The next slide is going to be about the reinforcement learning as well.
Sure, I can take it on from here. Hi, my name is Jaylin in Team 3. I'm going to present about the model link part for the reinforcement learning. So this is the preparation for the reinforcement learning, because in that we have a lot of little pieces we combine together. So first, when the user comes to us, we start from sentiment analysis, right? So we detect if their mood is positive, neutral, negative, or actually in 5 different levels. So positive, moderately positive, or neutral, moderately negative, and negative. So that's how we go about. And then we also detect whether they have some sign of depression, ADHD, or anxiety. So to get there, we need to find the best model for our sentiment analysis. So how do we find what their mood is from positive to negative? So we looked at many different models, including TextBlob, GPT 3.5 Turbo, BERT model, and Vader model. And also there's another one that using XGBoost, and we were using a different data set to train the XGBoost. But anyway, so we have 5 different models that we compared. As you can see, GPT 3.5 and BERT and Vader, they kind of looks like they are better performing than TextBlob. But if you see overall on the left side, they're all below 70%. They're below 66%. They're not actually very good at detecting the sentiment of our emotions, right? If you look at the right graph, that is, we are only looking at the positive and negative emotions. So it seems like a neutral emotion is very difficult to judge. How would you say somebody's neutral emotion? That's very difficult, it seems like. So when we look at only positive and negative labeled data, it seems like they are performing a little bit better, 76% and 70% and so on. So again, you see the GPT 3.5 and BERT are more like a higher performing model. So let's look at the next slide.
So we have some naive-based predictions here, which we put just for the purposes of showing here. The naive-based perform well in the category of ADHD, anxiety, and depression for predicting purposes. We just put this just for comparison purposes. So we have the reinforcement learning here. Jaden will talk about this.
Yes, I think we are missing one slide, but it's okay. I'll just I'm gonna talk about it. So we talked about positive and negative emotion detection earlier with those 5 models. So we decided to go with BERT model because BERT is free, right? GPT is you need to pay, and also BERT is performing better. And when we looked at the confusion matrix, also BERT was better at detecting negative emotions than GPT 3.5. So it's important for our purposes that to detect the mental health condition, we need to find out as much as negative emotions as possible so that we can provide support. So that was the rationale for that. And the second slide that the Yanni was just showing was for the model for detecting the which category of a depression or ADHD or anxiety the user might have, right? So we had a night base that she showed about like 80% around that kind of accuracy, and we had XGBoost model right here. So F1 score around 80%. And XGBoost was actually higher than 90 something percent. So we decided to go with the XGBoost model for that. Okay, next slide, please. So here, do you want me to talk or do you want to talk?
No, let's go for it.
Okay. So here, if I continue, this is our structure. I think we talked about it last week, so I'm not going to go too much in detail about that again. But in general, I'm sorry, it's a little bit blurry, but we go from bottom to the top. So bottom is the user input. At the top is the LLM output that is responding to the user. So bottom part, user enters something, and the yellow box is the chatbot, right? So the text goes there, and then after the blue box is a clean text. So we clean it up, and then we go to the left side, which is detecting the depression, anxiety, the ADHD using BERT. We chose BERT, not all of them from here. So BERT, and then we exit. We tell the pink box on the left side and say, well, this user might have this positive mood or negative mood and so on. And then using the reinforcement learning model that we have using Q learning. So we have a Q table with all these probabilities distributed, and we're using the softmax to choose the highest action, highest Q value to choose the appropriate action. So we get the action selected among the encouragement or empathy or actually spirituality. We used to have suggest medical help, so we don't want our chatbot to be too much suggesting, oh, you go see the professional, you go see the professional. We don't want it to be like that. We want it to be more emotionally supporting, kind of comforting type of support chatbot. So we're encouraging or empathy, or we're kind of spiritual support. So that goes there, and that determines the tone of the AI and that goes to as an input to the LLM model. And if you go to the right side, the yellow box with the diamond shape, so that is to detect the mental health condition. And so once you choose that mental health condition, then we will use that to choose which questionnaires that we will choose a question from. So we want to ask one question to the user related to that specific symptom we detected. So if it's a depression, we look through our depression-related questionnaires. That is like a medical survey, some sort of. So we get those questions, and then we pick one and send it to the LLM model. Then this LLM model is combining them together and make it a very nice short text, and they send it back to the user. So it doesn't look like a Google search sending a whole bunch of information. So next slide, please.
Yeah, this continuation for reinforcement learning. So
okay.
yeah, this is just a screenshot here.
Okay, so this is the screenshot. I don't know if you want me to do actual demo or just a screenshot. Yeah.
Yeah, you can do the demo after explaining this.
Okay, so this is a screenshot of our chatbot. We have 2 sections. On the left, we have a selection at the top. It's a drop-down menu that shows you can choose the questionnaire selection retriever, either BM225 or the Chromadb. So we have two options there. And the underneath, we have a behind the scenes section. So we can kind of see what AI is doing behind the scene. So I don't know if you can really read it, but I can show you in the demo. I think it's better to do that. But on the right side, we have the nice chat exchange that you see that it's not like super long exchange. So it's like 128 token size of a response from AI that goes nicely. So I think I'm going to move on to the demo part. So let me share my screen, Yanni.
I'll stop sharing here. Okay.
Okay.
Right.
All right, so everybody sees my screen.
Yes, good.
Okay, perfect. So welcome everyone. This is our demo for our FOMO fix, the reinforcement learning based mental health assistant. So now we have BM25, as I said, and also Chromadb. But just one note, for Chromadb, we didn't get to integrate the option to remember what question was already asked to the user. So it might ask the same question twice if the user types the same kind of a text about the same kind of symptom. So we are going to demonstrate with the BM25 for now. So in the behind the scenes, so let me type something. So hello, I'll start with hello. It's thinking. Well, at first we are loading the model, and then the model is actually training the XGBoost model behind the scene using the predefined data set that we used previously, and then it's outputting the data. So it was taking a little bit longer, but after this initial text, it'll be much cheaper. Much quicker because we'll be loading from a pickle file. Okay, so it's just saying, oh, okay, it's great to hear that you're reaching out. Remember, it's okay to ask for help. I'm here to support you if you ever need to talk. Okay, so there we go. I'm gonna say, hey, I feel isolated. I am on social media all the time. My friends seem to be having fun all the time, but not me. So yeah, we have a little bit of a cleaning issue that we need to do, but it did respond us with a LLM model respond us. So it's important to remember that social media can create an illusion of others' lives, and it's not always a reflection of reality. Try to find other ways to connect with your friends and engage in activities you enjoy. You could also consider speaking to a therapist or a counselor who can provide more personalized advice. And then there's another question that we picked from our questionnaire database from BME25. It's how often have you felt restless or slowed down most of the time? So let's dissect what happened here. So this LLM response actually comes from one of the Hugging Face model that we selected as a Falcon 7B. That was the model that we used. And this model detected the user tone as a moderately negative, and then compared to previous mood, the hello, mood decreased. So that is what it was detecting. And the possible mental condition detected as depression. And it only shows depression when the mood is negative or positive, because we don't want to detect any positive mood as a depression, right? So we just said, okay, well, give us this result only when the mood is negative, moderate negative, actually also when it's neutral. The reason why we included neutral is because how these models that we looked at before, they don't know very well of a neutral tone. So it might be negative tone that we might be missing out. So we want to make sure that it's included. Therefore, it's going to show for the neutral mood as well, the condition of the mental health. So next, the AI tone, it was taking empathy. The reason why is if you look bottom at the table, this is a Q table that is used for our Q learning or reinforcement learning model. So based on this moderately negative, if you look at moderately negative, so number 1 here, sorry, I clicked something. Yeah, sorry, I just 1, 2, 3, 4. So moderate negative, then the highest score, the Q value, if you look at it as a, sorry, was it? Oh, maybe I changed something, sorry. But it was supposed to be highest number, and therefore it was the outputting the empathy as the AI tone. So that went to the LLM model, and also the questionnaire that was selected from BM25 went to the LLM model, and therefore we got this message. So I can continue answering this question. I'll just enter one more text and then we'll be done with this demo. How often have you felt restless or slow down? Most of the time, maybe 2 times a week. I feel restless when trying to work. It's not uncommon to feel this way, and it's important to find ways to manage your stress and anxiety. Have you considered taking breaks throughout your workday or trying a relaxation technique like deep breathing or meditation? And also, we add one more question from BM25. Do you feel like you're stuck in a rut or that you can't see a way out of your current situation? So BM25, this is actually using TF-IDF as a behind mechanism to find a similar question that is similar to what user said. It's kind of comparing this and that. Okay, that seems like similar, so that is how it's pulling out. So that's the end of our demo for reinforcement learning. And I'll move on to the next person to present our next model. Yeah, New, you're on mute.
Yeah, sorry about this. Thank you, Chadin, for presenting this. We also have a Bibi as well. He's going to be presenting our RAG approach here. Feel free to unmute yourself, Bibi, so when you can.
Hi, can you share the screen, Yanni?
Sorry, am I presenting this? 1 second. Sure, it's not a problem. Okay, I'm going to present this now. Okay, so this is our form of X chatbot with the RAG approach. That's the second demo that we have. Maybe if you like to just, yeah, I can just input the questions here. For example, I can say that I feel sad, depressed, looking on social media. So we have our chatbot is going to print the question here, which should be obvious, and we have a response as well. And also we have a rating system here just to show that how helpful was this response here. Would you like to talk about what's happening behind the scene here, Bibi, behind the form of X?
Yeah, sure. Can you hear me?
Yes.
Sure. Okay, nice. So the second approach for our chatbot is using completely RAG, and as a model, we used Gemini Pro, and for the similarity search, we used FAIS, Facebook AI similarity search, for the similarity search and for the retrieval purpose. So as a knowledge base, we have a data set in the CSV and PDF format, and then we do the splitting, chunking, and all the RAG process. So to add some variety in our chatbot, like instead of serious question and answering, we added some fun way to interact with the user. So like our chatbot like reply in a fun way and give a good how to say, a good friendly chat with the user, and then finally we collected feedback from the user. The reason why we started collecting the feedback is to implement the LLAma, but due to time constraint, we can't able to do that. Yeah, we took some time, so this is our chatbot. If anybody want to try it, maybe we can share the link.
Yeah, I believe you already deployed it here, so it's available now for people to test it as well if they want.
Yeah, and if you have any question, guys, you can ask. We took some time,
So
so
for
it's enough.
yeah, yes, you can also go with the DAG sub repo and walk through what exactly your code base is.
I'll stop sharing here then. Sorry, yeah, do you want us to go for the DAX repo, you said?
Yes, yes, yes.
Okay, Abibi, would you like to share screen then for if we're going to be presenting the code for this?
Okay, let me share my screen.
Sure.
Okay, can you see my screen now?
Yes.
Okay, yeah. So should I go into all our repo or specifically for this chatbot?
Yeah, specifically for this chatbot, you can go for
Okay,
time
sure.
being.
Yo, okay. Yeah, this is our notebook. So we use Transformer, Torch, Fast Repo, and Google Generative AI, Gemini Pro. Okay. So here in the first year, we imported all the required libraries, and then first we do the document processing and embedding. For this purpose, we use the transformer model for the embedding part. Here we have our embedding function, and here we load our collected data base in the CSV format, and also we integrated some PDF files related to our use case. And next, we generated the embedding model, and we saved the embedding model as embedding.npy, and also saved all the data, the extracted data in text format. And after that, we did the retrieval and response function. So for the retrieval, as I said before, we used the Facebook AI similarity search algorithm. And next, we defined the function for our LLM model. And then for the augmentation and prompt template, we give the AI sound or the prompt for our Gemini Pro. And one problem during implementing this in the Gemini Pro for this mentalist, specifically for this mentalist thing, repeatedly Google doesn't allow such things, like it replies this sensitive topic or something like that. To handle that issue, we use this thing, block prompt exception. And yeah, after we define this augmentation and prompt, simply we can now chat with our chatbot. This one is the notebook thing, and with the Streamlit integration, this one. The same flow, the only difference is the front end part integrated with the back end. And to save the chat the chat story, we used shelf to save our thing, and also we use CSV to collect users feedback. Yeah, that's it. The code is like this. If you have any specific question, you can answer it. You are muted. Yeah.
Yeah, that's good, Abhi. The architecture is very simple and easy. So if any other team members have questions, you can ask right now.
Yeah.
No
So
questions,
yeah,
right?
may I please
So
confirm
yeah, we
with
can go ahead.
you? May I please confirm with you?
Yes.
That was our presentation of a code, and this was for the rack approach. Do you want us to present anything else about, or we're just moving on now? Just want to confirm this with you.
Yeah, we are moving ahead with team 5 presentation now. Is there
Sure.
anything else you need to present, Yanni?
No. We presented the code from a BB side, unless you want us to present anything else, or we're moving on. That's what I would like to confirm with you here. So I think no.
Okay, sure, Yanni. We can conclude the team 3 presentation. So now we can go ahead with team 5 presentation.
Sure. Thank you.
Okay, thank you. Thank you, Gia. Good job, team 3. Really like your creative thought process. So thanks for sharing. Appreciate it. So for team 5, I guess Haska, Ankita, if you can go ahead and share your screen. So for team 5, I want to set, we had some setbacks, and a few folks were sick on the team, and we had a limited contributors this week. But with the folks that we had, I think we were able to build the basic version of chatbot. But definitely, our focus is this week is build an advanced chatbot which we'll talk about that briefly. So hoping that we can present that next Monday. So for what we were able to accomplish this week is, if you can scroll to the next slide, Ankita, please. So again, basically, we implemented the basic chatbot. I think like team 3 that was demonstrating. So kind of I would say basic chatbot. So completed vector DB ingestion, which we'll talk about. Basically, we ingested both CSV and PDF files there, and we integrated with the RAG and be able to implement the chatbot in Streamlit, and so we can demo that. And then step number 3 and 4, we couldn't integrate again due to the constraints we had on the team. And but team was able to complete the step number 3, fine tuning SFT and DPO with the dataset collection, developing and training with one epoch. Team ran into some GPU challenges, so we're trying to find some resources this week from a computational resources standpoint. So we'll to do more epochs. And then integrate with our chatbot. So integration hasn't been done yet, but and the step number 4 again, LLAma Gaurd from an ethical consideration standpoint, and our team researched, and that analysis and development is complete, which we'll walk through it. But that we haven't integrated the LLAma Gaurd into overall chatbot yet. So we have a lot of tasks for us, team 5, to complete this week. So with that, can you move on to the next slide? So I guess maybe we'll come back on the, so again, maybe touch upon, so this week's focus is again, advanced chatbot, and then continue the fine tuning, we finding some GPU availability so we can do more testing, training, and deployment and integration. And similarly, LLAma Gaurd integration with chatbot, and deploy overall solution, and code checking, and then final report and final presentation. So that would be our focus area for this week. Yes, can you move? Good. Can you move on to next? Okay. So some challenges that we had, again, I just want us from on the team, right? So the folks that we have on the team, this is the first time they were getting exposed to the lang chain and the retrieval mechanism. So we had some challenges. I mean, I would say there's a technical challenges for any new technology stack, but the team was able to spend effort and learn and implement it. So really kudos to the team. I mean, definitely. I was asking the team this morning, so team was pretty happy the resources that were involved because they were able to learn and try and implement new things. So that's definitely boosted the self-satisfaction on these tasks. And so we had vector DB. We were able to ingest CSV and PDF, but ran into some challenges in hooking up to the retriever. Where we connecting the retriever when we had, especially when we have the vector DB at multiple collections. So had some challenges there, and step third number one, step number 3 is more around performance and GPU availability challenges, and also the last one is data availability, especially for SFT and DPO. Team had to spend time to figure out the data set for DPO from SFT tuning, and also for the DPO, we have to use LLAma API calls to generate synthetic data and to develop the chosen rejected responses for the DPO data set. So that took time. I wouldn't say these are really technical, they are complex challenges, but these are the areas where team had took more effort, that required more effort to figure out things. Okay. I think that concludes the presentation. Yeah, so just I wanted to call out I think the folks who have contributed there, and there's one new person reached out to us and, hey, can we, any tasks that we can help with? Drew, again, thank you, Drew, for reaching out and helping doing some bit of analysis there. So with that, I'll shift to the presentation. See if I can be able to do screen share, hopefully. Okay, can you guys able to see my screen?
Yes.
Okay,
Krishna.
Perfect. So I'll just quickly go through, again, this is a basic chatbot, which we couldn't get to the advanced chatbot that we were hoping for, but next Monday we can present.
Sorry, we
So
lied. We
sorry,
can't really see your
Krishna,
screen.
the presentation is not, presentation is not appear, but okay, so yeah, we can see the screen.
Yeah, I haven't shared yet, sorry, yeah, okay. So let me launch so maybe I'll go through the code after the presentation. So again, let me get to launch the solution. Launch it, actually, just give me. Give me 2 seconds. So this chatbot behind basically implemented in a basic RAG. We did the Chromadb vector DB implementation, and we used Mistral 7B instruct chat LLM, and we used the LLM, the All-Mini V6L2 embedding model. So basically, this is, again, as I mentioned, this chatbot, right? So you ask a question, provides a response back. So I'll just maybe take some questions, just some of them we haven't tried, some we have tried. So I just want to maybe show, for example, let's say if I do it. And just take one question. I'll say, for example, I feel so alone even though I'm always online. When we look at kind of these, again, from we've ingested like almost 11, 12 PDFs are there, and some CSV data we ingested. And it's kind of, I think the responses seem to be kind of reasonable. Again, through the prompt techniques, kind of tuned, and we further have to still further tune the prompt templates. But I think the response that we got here, it's understandable that despite being online, you might feel still lonely. Overuse of social media can sometimes lead to feelings of isolation and even worsen symptoms of depression. So I think it seemed to be proper kind of an answer. So I'll just continue with more questions, and then we can see, for example, social media is affecting social media affecting my sleep and mood. What should I do? So again, kind of find some of the health advice that we have in our VectorDB. Okay, I think it's kind of a decent answer there. Maybe we can pick something, for example, let's say if I ask something, I'm crying for no reason. These are just random questions that we came up with. Yes, feeling sad or emotion can be sign of underlying depression, anxiety. However, it's important to know that everyone experiences sadness and emotion at times. So kind of give some health advice there. And maybe one last question we try, and then maybe I try. So for example, why don't I enjoy things I used to love anymore? The bottom line is, I think the responses to what we got from VectorDB and semantic search seem definitely reasonable. Make sense to these answers make sense to us. So I think that with that, I'll dive into the code, and then my other team members will showcase the SFT DPO and also the LLAma Gaurd. Okay. So jumping back to the code. So like general RAG approach, right? So basically kind of ingested our CSV data and PDF data that we have. We kind of combined all PDFs into one PDF, like a 12 PDFs into one PDF, ingested into it, into the VectorDB. You can just quickly go through. So for example, here we used for PDFs, we used kind of parent and child retrieval mechanism, and then we kind of iterated through the files and folder, and then ingest each file into CSV. And also similarly for PDF, we would iterate through all the folder, and right now this we combine all the PDFs in one PDF and ingest it into the Chromadb, and then basically kind of return the retriever to the conversation retrieval chain. And then if I go to the LLM generator code, basically this is where we have so basically here we use the Hugging Face Mistral 7b, so connect to the Hugging Face API token, and I need to convert that into a secret. Now I know that's kind of a violation, which will fix that. But overall, we use this embedding model, Chromadb, this embedding model, and use that interface endpoint to call through. We called LLM API via Hugging Face serverless inference API, then installed 7b instruct, and then we used conversation buffer for the chat history, and then we defined as a system message prompt and the condensed question prompt, and use a chart prompt template, and then we connected to the conversation retrieval chain that kind of does the communication between the user and the LLM and our chat history. So and get the response, and kind of wrote code to separate it to kind of store human responses and the system responses, etc. And if we go to the app.py, so this is basically a Streamlit code. This is very basic Streamlit code. What we have basically kind of a response generator, and then basically you kind of do a UI handling role and system, and then display those messages there. So pretty straightforward. So this week, what our thought process is, we use similar to what Team 3 kind of demonstrated, but maybe a slightly different approach. But overall, the concept is, having kind of two agents approach. One chatbot, the other one is recommendation agent. So as the chatbot is trying to understand the user depression or user mental health situation, the recommendation agent, will try to tune the recommendation, change the advice, right? So kind of have that kind of a two agent interaction approach that we want to demo. Hopefully, we'll show it on Monday. So that's about this, and I want to switch topic to Mariam and Victoria have researched the LLAma Gaurd integration. Maybe I'll quickly walk you through that notebook. Mariam couldn't join. She has a conflict with her office meeting. So as you can see, not this one. 1 second. I think this is LLAma Gaurd. So Mariam and Victoria researched a couple how do we implement safety and ethical and non-toxic kind of behavior into the chatbot. So the research then kind of came up with this LLAma Gaurd interface. So the inference, what we wanted to go with. Basically, this is if I can just quickly. Yeah, so this is the Hugging Face LLAma Gaurd that we kind of wanted to choose to go with. And so what it does, the way it is, basically you provide the input and then it classifies. It's a kind of a classifier. It classifies whether it's a safe or unsafe. So as you can see, we are using this model, and as you can see here, it works as basically as a classifier for safe or unsafe content. You pass in the content and it can classify. And then one advantage of this one, you can configure the taxonomy, which we will show briefly. So you can based on the taxonomy, it can you can customize the categories, and so accordingly it can determine whether it's a safe content and unsafe content. So basically you call this API and pass the input, and then it can output the classifier. For example, if you see here, can you recommend this pasta recipe, and say safe. But as you ask, hey, can I? It says, for example, we asked, hey, I forgot how to kill a process in Linux. Can you help? And then it kind of classifies it as a safe. But if you start asking, forgot how to kill a person, can you help? Then it is unsafe. But when it classifies unsafe, right, you have some. It also gives you some the additional category number that you can see the list of categories that you can define. It does explain it is unsafe. Based on which category is it determining that it is unsafe. So it's also gives us that code, which will. So for example, in this, right, you see here, right, we say here, based on the question you asked, it classified as number 3. If you see there these categories that are kind of configured, you can see this is a criminal, kind of comes under criminal planning, right? So that's how it kind of determines. And for example, you can customize these groups, categories. And let's say if you ask, hey, tell me how to cut myself to feel better, then it says unsafe. And number 6, if you go back to it, it says number 6 is self-harm. So kind of self-harm category, right? So I think that's the idea. So the way we wanted to integrate this is, which we still need to figure it out, is deploy this and call this API and Hugging Face this model. And then it can classify safe or unsafe. Then accordingly, we can integrate with a chatbot. If a user asks these kind of self-harm and self-inflicting kind of questions, we can say, hey, this chatbot cannot assist you with this, and kind of put some safeguards around the chatbot, right? So I think that's our thought process. I think, I don't know, Victoria, if you are on the call, if anything else you want to add on this topic. I know you also researched this.
Yeah, so the thing is, we came up with this one solution with LLAma Gaurd, but if it will be difficult to implement, there is another one with LangChain, but it also uses OpenAI API. So I wasn't very sure about that since it's paid one. LLAma Gaurd, however, is free. If it will be easy to integrate, we will go with this one, with this final version. Thank you.
Okay, thank you, Victoria. So with that, we will switch to the topic to the SFT DPO. Devanjan, if you can take the screen share and walk the team through what we have attempted and what the challenges we are currently trying to overcome.
Yeah, sure. Let me share my screen.
Second, trying to see how to stop my screen share.
Is it visible?
Yes.
Okay, so I'll discuss about the training data, training script, and the challenges we faced in this model building. First, the training flow goes like this. First, we fine-tune with SFT, then align our model with DPO. And our training data, for raw data, we took this mental health counseling conversation. You can see this data. It has conversation with therapist and answers. Next is our SFT data. So with alpaca prompt, we format the data. You can see the instruction and the response. This is the instruction. And this is the response. And next is our DPO data. So this is our DPO data. So with RLHF prompt, we format the data, and you can see the columns: prompt, chosen, and rejected. Next is our training script. So we loaded the important libraries like PEF, ERL, and transformers. Then we loaded the model and the tokenizer. We used Mistral instruct model. We loaded in 4-bit precision, 3 bits and bytes config here, and we distributed the model with auto. Next is we loaded for SFT, we loaded the SFT data. We're taking just the prompt column. Next is the config. So we need 3 configs to run SFT: PEF config, the LLAma config, the training arguments, and the trainer config. So we used SFT trainer, and you can see the training arguments. We used a number of epochs as one, as discussed, as mentioned in the presentation. And yeah, finally we trained the SFT model for one epoch. We can see the losses oscillating. Last year it was decreasing. Next is the inference, how you can infer with this model. Okay, you can give the prompt, you can tokenize it with tokenizer, and you can generate your response. Okay. You can do decoding strat. You can use many decoding strategies here as well. You can do sampling, you can do beam decoding or top P, top K sampling as well. And then you decode the input IDs back to the text, and you can get the result. Okay. Because we train only for one epoch, the results are not great. Okay. Next thing is the DPO. Okay. Same flow goes with DPO. We loaded the DPO data set. We created the configs, LLAma config, training arguments, DPO trainer. And yeah, one hyperparameter mentioning is the DPO beta. We set to 0.1. Okay. And we train the DPO model for one epoch. You can see the training loss. It is cross entropy loss. Okay. Next thing is the model architecture. Okay. And LLAma, we inject 2 matrices. You can see the LLAma A and LLAma B matrix. Okay. So this is our Mistral model architecture after some tuning. Okay. And the inference is same as SFT. You have to use the tokenizer to tokenize, then the generator, and then decode back to the text. Okay. And yeah, the challenges we face now with free Google Colab version. One, we don't have much space. I think it's 15 GPU, and the older GPU model as well. Yeah, I think they're providing the T4 model. Okay, so we cannot train with more number of epochs. So we'll plan to train number of epochs this week. Yeah, that's an presentation. Krishna, want to say something?
Krishna, you can unmute yourself.
Sorry, thank you, Ahia. Yeah, so this is what from the team 5 for this week, and we have a lot more things to do this week, and we hope to come back and we're kind of an advanced more presentation demo for next Monday. Okay,
Yes,
back
sure.
to you, Ahia.
Krishna, thank you. Yeah, yes, great job, team 5 and team 3. Applause to team 3 and team 5. So yeah, I hope every team, all the teams can do the same demo. We hopefully see few more demos on Wednesday. Any more questions? Does anyone have any questions? Okay. So yeah, so Wednesday we'll be having few more demos, and yes, who is there?
Okay, I have one
BB.
question. Yep. Like as the team 3, we thought
Okay, go
the
ahead.
code and the demo is final day is today, and that's why we are in a hurry and do such kind of things. So should we also present the next demo by next Monday, or only next Monday we present the final presentation?
Yes, yes. So you can have your final demo on. You can have final demo on next Monday.
Okay, good.
So if possible, if you are doing some modification and upgrades, you can also present on Wednesday.
Okay, good. Okay.
Yes, yes. Thank you all for joining today's session. Hope you have been great learning experience. So, if any questions till date in terms of incorporating any features or how the responsible AI ethics works, right, as implemented by Team 5, you can also look back and see how you can implement in your model. So yeah, so just motivate your team, complete the given task, build the product. You can go ahead with few more demo updates on Wednesday. So yeah, then thank you all for joining today's session. Have a great day and have a great learning experience. Bye.
Bye. Thanks, teams. Great job. Thanks, Yaya.
Thank you all. Bye.
Thank you.